Hello friends, welcome to Shiksharthi. In this session, we shall be discussing how to find out whether a given triangle is an acute angle triangle or not. So let's start. Now the very first thing that is expected out of a learner for this session is we should know the criterion for similarity, congruency, law of perpendicularity and law of parallelism. These are the four things that we need to know before we go ahead with this session. Now here I am drawing a triangle with the vertices x, y, z. Now nowhere have I stereotyped the triangle. I mean I have not prototyped the triangle in terms of that this is a right angle triangle or it is an acute angle triangle or it is an obtuse angle triangle. I have not stereotyped it because what we are going to do in this session is we are going to check or we are going to find out a method how to check whether a given triangle is an acute angle triangle. Meaning thereby, in the very first place, you should know what is the definition of an acute angle. So the definition of an acute angle is when an angle is made between two transversals or two line segments or two lines such that the given angle lies between 0 degrees to 90 degrees. Between. Now the moment we say or we use a word like between, that means the extreme values are excluded. So that means we are not talking about 0 degrees and we are not talking about 90 degrees, but we are talking about all other values which lie between 0 degrees and 90 degrees. That is the definition of an acute angle triangle. Now what are we going to use here? So I am drawing a perpendicular here. So which is why it was said that the law of perpendicularity should be known to you. Now law of perpendicularity basically ends on, or let's say starts with the Pythagoras. Okay, so now we have drawn a triangle and inside a triangle from one vertex on to the other, the opposite side of the vertex, we have dropped a perpendicular. Okay, once we have done this, now we can apply Pythagoras theorem. So applying Pythagoras theorem, so Pythagoras theorem says, so when we talk about triangle XYW, so in triangle XYW, we can say that XW whole square, which is the perpendicular, is nothing but the difference between the hypotenuse and the base. Similarly, in triangle XZW, so here in the first case we were talking about the triangle XYW, and in the second case we are talking about the triangle XZW. Now in this triangle also we will say that XW whole square is nothing but the difference between the square of the hypotenuse and the base. So let's assume that this is equation 1. Similarly, let's assume that this is equation 2. Now we know that the left hand sides of the equations, when we talk about equation 1 and equation 2, is the same, so we can equate their right hand sides. Now when we are equating their right hand sides, what are we saying basically? We are saying that xy whole square minus yw whole square is equal to xz whole square minus yw whole square. I'm sorry, wz whole square. So from here, can I say that xy whole square is equal to xz whole square? Plus, now I am combining these two. I am combining yw whole square. What is the logic of combining yw and yz? Because yw and z are those points which lie on a straight line. Now the points which lie on a straight line are termed as collinear. Conversely, collinear points are those points which lie on a straight line. So this is the second thing that you have come to know here. So now can I apply, now we all know that there is an algebraic expression. If there is an algebraic expression a square minus b square, how to factorize the algebraic expression a square minus b square? So here we are going to use the concept of a square minus b square, which can be factorized as a minus b into a plus b. Okay, using this concept and applying here in this equation, which we can term it as the third equation, which we are getting as a byproduct of combining the first and the second equation, we get yw minus wz into yw plus wz. Now this conclusion or inference is going to be very important, and this can be used as a lemma to deduce many other things as well. And as you would have seen in our other sessions also, we always focus on the concepts, the formulas. We take the formulas as questions, we take the concepts as questions, because if we can't solve those formulas or concepts as questions, further it becomes very difficult to apply those formulas or concepts into unknown questions. Now there is a difference between a known question and an unknown question, which as a learner you should know how to differentiate between the two. Okay, going forward, can we say that this is nothing but xz whole square plus, now we know that the point W did not exist in a triangle and it was made to exist. So now let us come out of it and let us convert yw minus wz into something, into the points which originally existed inside the triangle or outside the triangle xyz. So now we can put this yw plus, I'm basically talking about this, we can convert it into, this can be converted into yz, because yz is nothing but yw plus wz, and these are three collinear points. So this I can write it as yz multiplied with, now we know that w is a point which has been made to exist. Now let us try and eliminate it, or can it be eliminated or not? Let us see the same. So can I write yw is nothing but yz minus wz and minus wz further, which further can be written as, so we come down finally to, now xy whole square is nothing but xz whole square plus yz into yz minus 2wz. Now eventually we can write this as xy whole square is nothing but xz whole square plus yz whole square minus 2 into yz into wz. We get this as a final conclusion. Now, how is this going to help me will be decided by when you substitute the values of all of these. Now, when you are substituting the values of all of these, and let us say that there was a triangle that was given to you, and the triangle that was given to you was xyz, as we started off with the same triangle, such that they had given you the values of all the three sides. So let's say that xy was A, xz was B, and xz was C. In that case, let's assume that yw was x, we assumed it, and this, in that case, wz comes out to be C minus x. So do we know the values? Yes, we know the values. The only thing that we did not know here is the value of x, which we can deduce with the help of equation 1 and equation 2. Can we deduce the same? Let's see. Now here, and I'll just keep on ticking. I mean, can we deduce it or not? xy, is it known to us? Yes, it was originally known to us. So I'm using a I'm using a green colored pen here. Is yw known to us? No, we have assumed it to be x. Is xz known to you? Yes. Is yz, is wz known to you? In a certain sense, yes. So can we find out the value of x? Yes, we can. So this is the way in which you find out with the help of the sides that whether the given triangle is an acute angled triangle. And once you are able to do this, substitute the values, you are able to do this. So you come to a conclusion which says, if I have to find out an acute angled triangle, whether the triangle is an acute angled triangle or not, so we are trying to find out whether a triangle is an acute angled triangle or not. In that case, there are two ways of finding it out. One is with the help of at least two angles given in it. So now at least two angles given, if there are two angles which are given and both the angles here are lesser than 90 degrees but greater than 0 degrees, in that case it is an acute angle triangle. Is that correct? No, that may not be correct. So when we are writing here, what I wanted to write here was at least two angles. So this is not correct, but in that case, what is the correct version? The correct version here is, if I am deducing a triangle, if at least two angles are given, can I infer whether it is an acute angle triangle or not? I can. So one is with the help of angles we find out whether the triangle is an acute angle triangle, and other is we find it out with the help of sides. So in this case, if we have to find it with the help of angles, if angle y, angle x and angle z, if each of them is greater than 0 degrees but lesser than 90 degrees, in that case it is an acute angle triangle. Similarly, when we are finding it out with the help of sides, then it should satisfy this equation. It is then only you can term whether the given triangle is an acute angle triangle. Last but not the least, So when we are talking about triangles, and then we are talking about angles, and now here we are talking about angle X, angle Y, angle Z. What is that we can infer from the discussion that we had in this session? So one is, let me use AA for acute angle, and I'll be using OA for obtuse angle. So one case is all the three could be acute angles. In that case only we call it as an acute angle triangle. In the other case, one angle could be a right angle triangle. That also you can prove here from the existing. I mean, you know that XWY or XWZ is a right angle triangle, and the remaining two angles would be acute angle or acute angles. Third case here is one angle could be an obtuse angle, and the remaining two angles will always be acute angles. So when you talk about triangles, especially with respect to the angles, the three angles of a triangle, these are the three different type of triangles that you can get. So here you have an acute angle triangle AAT, or you get an obtuse angle triangle which is OAT, or you get a right angle triangle which is RAT. There is no other variety of a triangle that you can get. Please practice this, because this proof will be used, or this concept will be used as a lemma in the derivation of some other concepts or proofs.